Today we are going to be discussing the ways in which Newton's second law of motion is displayed by a moving ball at constant velocity. Newton's second law of motion describes the relationship between force, mass, and acceleration. In this lab, we will be focusing on how the forces from the surroundings changes the acceleration of the ball given it has a constant mass. We will be using video analysis and computational model to compare the predicted and observed behavior of the ball. Using the data collected, I calculated the initial and final values for position and velocity, as well as acceleration and net force, which will be used to obtain the computational model of the predicted position with respect to time. Here are the known and calculated values that I used for the computational model. This code represents the system properties and initial conditions, which is then used to determine the velocity and position of the ball at equivalent timestamps to the experiment video. When we run the code, we see the model and the graphs for position versus time and velocity versus time. At the bottom, the data set for the position versus time graph is shown, which will be used to compare the results. Here are the observed versus expected positions of the ball according to time, which shows that they vary slightly. This can be due to unaccounted forces such as friction and gravity. This opens questions about how acceleration can change due to force. For example, if the ball traveled across carpet, there would be more friction and overall less net force acting on the ball, due to the opposite magnitude of the friction force vector. The observed values may contain some human error if the ball was not rolled perfectly straight or if the center of the ball was recorded inaccurately during video analysis. Not only are we able to question the surroundings of the system, but we can also consider the measurements within the system itself. As we experiment with Newton's second law of motion, we can also ask how mass would affect the system. I used a tennis ball, but I could have chosen something lighter or heavier. If I had chosen a bowling ball, which was then rolled at the same acceleration, the net force would be much greater. And vice versa if it was something lighter such as a wiffle ball. Overall, this experiment compares how closely a system follows its predicted behavior based on Newton's second law. Most importantly, it shows how net force can be calculated given the few variables of mass and the position versus time chart, which then allows for further measurements to be made. It shows the many ways in which a simple motion can be described in physics using vectors and measures. Although this experiment is relatively simple, it shows the complexities of interaction between system and surroundings on just a simple scale.